So first of all, we are going to discuss the name of our subject. So our subject is a sub-branch of theory of machine. Theory of machine is a branch of science which deal with the motion and force in elements of machines. Okay, so there are two subtypes are there. One is a kinematics of machine and second is a dynamics of machine. In kinematics of machine, we are going to study only motion between the elements of machine, okay, without considering the force. Whereas in a dynamics of machine, there is a consideration of force and motion both. Okay, so in our syllabus, there are major portion is related to kinematics of machine, and some portion are also there in which we are going to consider the force also. So that's why our subject name is a kinematics and theory of machine. Okay, so first of all, why we need to learn this subject? Okay, as you already learned in a previous semester, like you can see here, reciprocating steam engine. So you know the how it's working, but the number of elements are there and how they are connected, we are going to learn that in this semester. Okay, so how crank is rotating, how crank is transmit the power to the connecting rod, and connecting rod give the motion to the piston, and piston is reciprocating inside the cylinder. That's how you will learn all about the elements, motion of these elements. Okay, so maybe some students are thinking about we are going to study lots of machines here. No, as you know that machine is an assembly of mechanism, different mechanisms. So we are going to study only the different types of mechanism in this subject. Okay, you can see here the reciprocating compressor is here. Okay, and you already seen the steam engine. Both are different machines, but they are working on the same mechanism, which is a single slider mechanism. There is a crank, connecting rod and piston. Crank is rotating, connecting rod, connect the crank and piston. And piston is reciprocating. So this type of arrangement you can see in a steam engine and compressor in both. Okay, but the output and input are changed. Like you can see in a steam engine, input is a steam power which is work on a piston, and our crank is rotating and our requirement is a rotary motion. Whereas in a compressor, the motor is connected to crank, we give the rotation to crank and it is transmitted to pressure energy of air or compressed air. So there is another output is there. So same mechanism can be used in a different types of machines. So we are not going to study different machines, but different types of mechanism or very common type of mechanism which are widely used in different machines. So in this our subject, first of all, we are going to study the mechanism, types of mechanism, how can mechanism working, and then synthesis and analysis. In synthesis, we are find the dimension of mechanism, and then analysis. Analysis means we are going to find the velocity and acceleration of any point on a mechanism. Then there is a third portion is also there in which we are going to study the friction, how friction works between two surfaces, and then application of friction. Okay, so our subject cover these 6 chapters. Okay, so first is a introduction to mechanism, synthesis and analysis of mechanism, belt, rope and chain drive, okay, gear and gear train, friction, clutch, brake, and cam and follower. Okay, let's discuss one by one. So first chapter is an introduction to mechanism. Okay, in this chapter we discuss how the mechanism assemble, how kinematic links connected and they make the kinematic pair, and pair connected in a such a way that makes the kinematic chain, and using chain we can get the different types of mechanisms. Okay, so we are going to study different types of mechanism in this chapter. You can see here there is a 4-bar chain, and which is used in a different types of mechanism. You can see here the beam engine. So second chapter is a synthesis and analysis. Okay, synthesis means finding the dimension when there is a required input is given and we have to find the output. So we are going to synthesis of that mechanism and we will find the dimension, length of the links. Okay, there are 2 methods are there, analytical method and graphical method. And after when you find the dimension of whole mechanism, mechanism, then you will analysis, velocity analysis of that mechanism. And in analysis, you will find the velocity, acceleration or displacement at any point in a mechanism. Okay, like crank is rotating. So where will be the piston? What will be the velocity of piston? What will be the acceleration of this piston? So this type of data we can obtain from the analysis of mechanism. Okay, first chapter is a belt, rope and chain drive. Okay, in this chapter we are going to study these all three drives in a types of drives and how we can get the velocity ratio. Okay, in a belt drive you will learn the types of belts are there, types of belt drives are there. You will learn the length of the, how you can measure, how can you decide the length of belt. Okay, so this type of data you will learn in a belt drive. But some limitations are there in a belt drive. You can't use the belt drive for this larger distance between two centers. So that's why we will study the rope drive, okay, which is very reliable for the larger center distance. And then at last chain drive, because belt drive and rope drive not a positive drives. Possibility of slippage is always there. So chain drive we can use for the constant velocity ratio. Okay. So next chapter then is gear and gear drive. So in this chapter you will study first gears, types of gears are there, spur gear, bevel gear. Okay, and after that you will study the how the gear working. Okay, because in this chapter we will study individual gear, and after that the assembly of gear, means more than two gear connected and transmit the power, then it is known as a gear train. So we will study the types of gear train and how you can find the RPM or direction of any gear in this system. Okay, so these two very important chapters are there, gear and gear train, and you will learn how the gear drive works. Okay, next chapter is a friction, clutch and brake. Okay, in this chapter first of all you learn the what is a friction and how friction works between two surfaces. After that you will use this friction in a clutch and brake. As you know that the more friction between the clutch plate, you can transmit the more power. So basically friction is very essential for the brake and clutch. So after that we will learn the clutch, types of clutch and how you can find the torque transmitted by the clutch and what friction minimum required for the transmitting the torque. Okay. After that you will learn the brakes, types of brake are there, and there is also you will find the friction between the clutch brake plates. In the last chapter you will study the cam and follower. You can see the rotary motion of cam is transmitted in the reciprocating motion of the follower. Okay, which is widely used in a IC engine because exhaust valve is open and closed at a very high speed. How we can operate that? Using the cam. You can see the profile of cam which operate the exhaust valve. So we will learn how this cam profile is working. Okay, we will design the cam profile because we need some for data is given like there is a for 90 degree we want to open the valve, and after that for 30 degree we want to close the valve. So that type of data is given, and we are going to design the profile for which we will get the output. Okay, and it is also used in textile industry and paper cutting industry. Okay, so you can see now let's discuss the teaching and examination scheme. Okay, it is a 5 credit subject, 4 for the theory and 1 for the practical. Okay, 70 marks exam will be, as you know, the G2 university exam will be there for 70 marks, and 30 marks will be for internal, which we will get from the mid-sem exams. Okay, thank you.